Yeah, good evening everyone. Today's session is on decision tree, how we have decision, how we implement decision trees in Python. What is the use of this decision tree? What are the different how we implement this algorithm that is decision tree? What are the examples? How we basically have different terminologies in decision tree, right? So whenever we have to take any decision, we make a tree like structure. Like it may be containing some true or false part, or maybe based on the conditions it is decomposing into later stages, right? So what is decision tree? It is a tree like graph with nodes. There are some nodes which is representing the place where we can pick an attribute and ask a question. So you may be asking number of questions in this, and the edges are basically representing the answers to that particular questions. And you may have leaf node, you may have terminal nodes, you may have intermediate nodes, you may have subtrees also. The leaves represents the actual output or the class label. So this is how we have a tree like structure in a program. Let us see how we represent it in a like uh, via diagram. So the first node is like this. So this is the first node that we call it as a root node. So it is the root node where our problem starts with. Now we decompose this root node or this decision into number of nodes, right? So this is, you may be taking a number of another decision or another condition is there. This is one condition, and this is another conditions we have, right? And after that, this decision may be decomposing, maybe giving you two suggestions. So it is again divided into number of things. So the last node, the terminal node of the tree is called leaf node, which don't have any childrens, right? They don't have any childrens. This particular node has two childrens. One is this and another one is this. And if we are considering this particular part, we can treat it as a separate tree, or you may say it is a subtree, where you may have this decision node and you may have two leaf nodes also. And on the same side, on the other side, we may have the this is the decision node, right? And these are the leaf node, and you may have another decision node, and which is another decomposed into two nodes. So here we can understand this thing. The first basic node is called root node. A root node is again decomposed into number of nodes according to the decisions. Like I would be telling you how we basically apply this in a real time scenario, right? Before going into the detail, we must understand whether the data type, whether the variable is a categorical or it is a continuous variable, or it is a real value. Let us see both of them. So here we have if we are talking about, there are two types of decision trees that are based on the target variable. Target variable is your output variable, right? That could be a categorical variable, that could be a continuous variable for making your decision tree. So it is not only meant for your for calculating the real values, or like you have regression. You may have a categorical type of output variable where you want to classify your problem, right? So maybe you are defining your decision tree for categorical type of data, or where you are using your calculating the output variable that is a real value, right? So let us understand both of them. The categorical value variable or a decision tree is what? A categorical variable decision tree includes categorical target variables that are divided into categories. For example, the categories can be yes or no. Your categories can be your gender, male or female. Your categories could be pass or fail, your result. Your categories could be spam or not spam, right? The categories mean that every stage of the decision process falls into one category, and there are no in betweens. So basically in this we have just two types. Like here, if I want to define it, I am going to define it. My output variable would be holding the values that are of two types, two categories. either it is true or it is false. So it depends. It depends on the condition. Like if the condition is true, then your categorical output variable will be holding true, otherwise it would be holding false. Or you may say the result is pass or fail. Or you may say the gender is male or female, right? Or you may say your mail that you have received in your inbox may be a spam or not spam. So whenever your output variable is in a what categorical type of variable, that is holding the values that is falling under some categories. So let us talk about some of the value output variable that is holding a continuous target variable. For example, a continuous variable decision tree is a decision tree with a continuous target variable. For example, the income of an individual whose income is unknown and can be predicted based on available information, their occupation, age, and other continuous variables. So, suppose I want to check it out in a graph. I want to check out the values of x and y on different parameters, and then I'm going to train the model with some predefined data set, and then I'm going to predict what would be the value here, right? What would the real value, like these are the patterns. So patterns in the data would be here: occupation, age, and other means you may take any other pattern also, any other attributes. Suppose I want to check out the stock prediction, like price of my stock after 2 years, right, based on the previous pattern of that particular stock, of that particular share. Or I want to invest in some mutual fund. I may be referring to some of the websites where I may be searching for some of the mutual funds which are offering good outputs later on. So it is going to give me some value later on. Or I want to check out, like after 5 years, what will be my salary, right? I'm predicting my salaries after 5 years based on my current pattern. Like my current pattern would be a DA, would be HRA, would be TA, would be my basic level, basic pay level. So these are some attributes that is holding some output variable, and that output variable is your gross salary, right? And now I'm giving, now I want to predict the real value after 5 years. So I may be having a regression kind of thing, or a output variable that is holding some value, not a category, right? It should be like your salary would be this much. So it is some value. It is not like you may have a uh, yes or no kind of thing. So there are two things. If we conclude this thing, the decision trees, like I'm taking the example, uh, after 5 years, how much salary would be increased? I'm predicting for myself. Predict my salary after 5 years, how much it is going to be increased. How much means some figure should be there later on. And the second question is, after 5 years, will my salary will increase or not? So this is a question, yes or no. So this is a categorical type of decision tree when I am going to implement such kind of problem, right? So there are two things. One is the classification when we have some categories. The another thing we have a decision tree which is basically calculating on the continuous variable. Now let us see from this example. I have taken this example as like the first node, am I hungry? This would be a root node, and this root node is again divided into, you have some condition. If the condition is true, you may be taking this decision. So this node will be there, right? Or if this node is no, this decision is no, you may be taking this decision. So this decision would be a leaf because it is not divided further in the program. So this would be a terminal node or a leaf node. We call it as leaf node. All the nodes which are not later on decomposed, they are the terminal nodes. They are the ending nodes, you may say. So this node, and this node would be treated as your leaf node. And this node would be a root node, and this you may take this tree as a subtree as well. This tree, this particular part, right? As we have mentioned in the previous slide also, right? So this is how we how we prepare a decision trees. So based on some decisions, let's take another decision tree. Weather. Now weather could be sunny, weather could be cloudy, weather could be rainy. If it is sunny, you may be facing humidity, and if the humidity is high, right? If the humidity is high, then you are not going outside, right? If it is normal, you are going outside. This is this kind of scenario. If you have taken cloudy, you may be going outside. Weather is good. Rainy, if it is again, if it is have wind in the rain, if it is strong wind, you won't be going outside and you're planning for a trip. And if it is weak, you may be going to watch a movie, or you are going outside to have a picnic outside, right? So this is how we make decisions, right? It is basically usually meant for making the decisions. That's why its name is decision tree. You are taking multiple decisions, you are decomposing the problem and taking the decision on each step and checking out the condition as well. So based on the condition, you may have different scenarios. Now, how we implement this decision tree using Python, right? So when you are implementing decision tree, you may be having the first library that you need to include is sklearn, right? In Python, sklearn is a machine learning package which includes lots of ML algorithms. So we have predefined formulas, we have predefined algorithms that I can use with the help of this package. I can use with the help of this package, that is sklearn, right? Second package we have, and that package is going to have all that same things. Like if you want to calculate your F1 score, your accuracy, your recall, your precision, everything can be calculated. You may have modules like train, test, split. You may have cross validations for checking your testing and training data, or for changing the value. You may have decision tree classifiers, or you may have used random forest ensemble techniques. So it depends according to your requirement. Next, the second library that may be using for having such kind of thing is it is a numpy. Numpy is what? Numpy is numerical Python. Basically it is a module for having calculations on maths, like numbers, right? It stores the mathematical functions for performing any computation. It could be in, addition on arrays. It could be like if you want to insert zeros in your matrix, anything, you can use it with the help of numpy. It is used to read data in NumPy arrays and for manipulation purpose as well. So there is no limitation in this. Like if you perform, if you want to read some data in from an array, or you are reading some, you are inserting some values in an array, you may be using that. Or like suppose I am saying ki the graduation result is declared. Now the university wants like this question should be given as a grace marks to the students. So I may be using some list, and I would be using some numpy arrays, and directly using the formulas I am adding two numbers to each of the students in the list or in the array. So direct manipulations can be performed on your numpy arrays because it is holding the homogeneous type of data, or you may say arrays is holding the numbers value on which you can perform the manipulations. Pandas is basically data analysis for Python. Whenever you have a large data set, like a huge bundle of records it is holding, and you want to visualize the data, you may be using matplotlib for that. But if you want to import that data set, you want to analyze from that data set, you want to drop some columns, you want to drop some rows, you want to drop some records, you want to check out the first 10 records, you want to check out the last 10 records. So there are a number of formulas, there are a number of functions we have in our pandas. You may be taking it as a series, you may be taking it as a data frame. Data frame is nothing more than your database table. It's like a database table, right? So you may be imported your, so the flexibility is, the Python is holding a predefined packages, right? What are those packages? Like you have a reader for reading the CSV files. Now, what are CSV file? They are basically easy and simple to use formatted files that are comma separated values. It's just like your Excel files. It has provision for reading. It has a reader for reading the Excel files too. So it is according to your extension, whatever data set extension you have taken, it is going to perform manipulations on them, right? So it is up to that. So you can read and write different files. Data manipulations can be done easily on data frames. So data frame is nothing more than your database tables. And you may have other packages also, like we may be using matplotlib, like for plotting the different graphs, for checking out the relationship between the two variables, or you are predicting the errors, like what is the testing loss, what is the training loss. So you may be using, or you may be using you may be using the sklearn functions. So there are, these are the different packages which we can use in a programming using decision trees, right? Now let us see what are the different advantages of decision trees. Okay, it is basically good for interpreting data in a highly visualized way. So there is nothing, no code is there. While using decision tree, it's very easy to understand. Like if this is the decision, this is divided into number of decisions. If it is true, you are moving to one place. If it is false, you are moving to another place, right? You can easily extract the leaf nodes, you can easily understand what are the different branches, you can easily understand what could be the different subtrees in this particular decision tree. So this is a visual representation of your uh, data, right? Good handling a combination for numerical and non-numerical data. So your data could be, it is not meant for only categorical type of data. That's what I am telling you. It could have a categorical type of data as well, right? Easy to define rules, for example, yes, no, if, then, else. So like we have conditional statements in our programming languages, we can use decision trees as well. Requires minimal preparation or data cleaning before use. So you need not have to prepare your data or you clean your data, you directly use it, and later on you may find it, like if there is an error, you may increase the number of decision trees, or you may say the estimators, right? Like when we use assemble techniques, we may be increasing the number of decision trees for making the decisions. Great way to choose between best, worst, and likely case scenario. So when you have to take the decisions, and that too depends on what could be the best scenario, what could be the worst scenario, what could be the in between, like likely to be a good scenario. So it can be easily, you can trace out easily by deciding from the picture, right? Now, next thing is, can be easily combined with other decision making techniques. So that's what I told you. There are number of techniques which we can use for making the decisions or for classifying the data, right? Like decision tree is one of the classifier which may be holding, which may be used for solving the regression, or you may say classification problem, right? But we may use such kind of decision trees under ensemble techniques, which is basically boosting our data, which is boosting our training and testing data sets, right? So this is how it works. right? This is how it actually works. So let us see some of the disadvantages part also. When we are talking about the advantages, let us see the number of disadvantages. So overfitting. Overfitting is what? Overfitting, where a model interprets meaning from irrelevant data, can become a problem if a decision tree design is too complex. Yes. So sometimes you may have such kind of data set where you are using the data which is basically used for, it is not recommended to use the training data set for the testing purpose also, because it leads to overfitting. Whatever you have, it automatically overfits in your data. It is going to have like everything is okay in your data set, because your data set is too small, right? So it gives you a problem of overfitting. It leads to the problem of overfitting. They are not well suited to continuous variables which can have more than one value, a spectrum of values. So yes, sometimes it happens, but not all the times, because it can be used for regression problems as well. So when we have more than one variable, when we have more than one value, so it may lead to an, it sometimes becomes complex. In predictive analysis, calculation can quickly grow cumbersome, especially when a decision part includes many chances of variable. So, whenever you are using the decision tree, make sure you have sorry, a yes or no kind of situation. If it has number of multiple selections, if you have multiple conditions, it may decompose it, but your decision tree becomes more complex in that case. When using an imbalanced data set where one class of data dominates over another, it is not easy. It is easy for outcomes to be biased in favor of dominant class. So whenever you collect the data set, it should be containing all the constraints, right? Otherwise, may be possible like your outputs that are reflecting would be biased, and later on your system is unsuccessful, or you may say it is not accurate. It is going to hamper your accuracy part if you are taking the, if your decision making decision trees is making the biased decision towards any class, or the class is dominant, though that makes a difference obviously. So your model is going to be fail in that case, right? So that means your performance of the model would be poor. Generally, decision trees provide lower prediction accuracy compared to other predictive algorithms. So basically, whenever we use decision trees, now we basically used it with random forest or ensemble techniques, because there we want multiple parallel processing of decision trees rather than having a single decision, right? Based on single decision, it would be like different answer, and based on parallel decision trees which is giving a corresponding answer, and then again a voting should be there, a system should be there in random forest when we are implementing the ensemble technique. So obviously we are getting the accurate output in that case, but only decision making, only decision trees, sometimes it becomes complex, right? But it has its own advantages also, because it is very simple to use. So when we have such kind of data set which is cover all the scenarios, then you can take the decision taking decision trees as an algorithm. Now let us see what is the summary, how we can conclude the decision trees. Decision trees are straightforward to understand yet excellent for complex data set. Yes, what I said is you may be taking a data set which is covering all the constraint. It should not be biased, like I am taking the data set of only females, I am taking the data set of only males candidates. Why not I am including the all the data set of the data set that is including all the males and females data, and it should be in some ratio, right? So let us summarize this thing. Decision trees are composed of three main points: decision nodes denoting choice, chance node denoting probability, and end nodes denoting outcomes. So we have choices, we have probability, and we have outcomes in our decision trees. Decision trees can be used to deal with complex data set. Yes, it is shown also, and can be prone to, if necessary, to avoid overfitting. Yes, it would lead to overfitting if we have less amount of data, but if we have huge amount of data set, it is not going to deal with that, right? Yes. So let us see the next summary. Despite having many benefits, decision trees are not suited to all types of data, like continuous variables or imbalanced data set. So I told you, I have discussed this thing. Whenever we have balanced data set that is not biased, and we have collected the data set of all areas. Suppose I am making a uh, I want to make a cluster of four villages in the rural areas. So what I am going to do, I have to select all the villages which are nearby. Then only it is going to make a cluster, right? And if I'm making such type of selection, like one village is in some other state and another village is in another state, and I want to make a cluster, will it be possible? Because it is having the data set, but they are imbalanced data set. And later on, my algorithm is not going to provide me the accurate results as well, right? So we need to check upon two things. Like it may be possible, like sometimes it give you error with continuous variable, but it is more accurate with your categorical type of data, when you have to make the decisions like true or false, or yes or no type of thing, right? They are popular in data analytics and machine learning, with practical application across sectors, for healthcare to finance and technology. So you may be taking a decision in terms of, like I told you, in healthcare, whether should I uh, like an AI, want to use an AI model that is going to predict whether the patient should take this drug or not, right? Or whether the patient is going to have this medicine and no effect should be there after taking this medicine, based on the previous patterns of this. So yes or no kind of answer I want from that AI model, right? So based on the patterns, like the patient is having the BP or sugar, what is the level of the sugar, what is the level of, like what is the pulse rate, what is the previous history of that patient. And it may be like some patients are having their drug history, they may be showing some allergic reactions using some, like having some medicines. So based on that kind of model is going to have some categorical type of data, which is going to help out the doctor for making the decision whether to prescribe, sorry, whether to prescribe the medicine or not. So how it is going to happen with the help of like some algorithms, and it would be helpful using decision making systems, right? Another system is like finance. I may taking like this policy, and whether it is going to benefit in future, yes or no. What is its previous records, whether on the same patterns, like same salary, same infrastructure I am using, same type of profession I am having, based on the previous data set, it is going to predict, like for the previous persons, for the earlier, like earlier the person who, those who are having such kind of policies are having this much, they are benefited with this policy, yes or no. So when you have categorical type of data, you need to have such kind of algorithm, right? Decision trees are the best algorithm when you make decisions with categorical type of data, right? So it would be better, like if you are referring if you are using decision trees in making such kind of decisions, rather than having the calculation part, right? Like what will be my salary, I'm going to have some value, real value, right? And that is going to be predicted. So maybe it happens like with some data set, maybe if the data set is imbalanced, maybe it is going to provide some, the accuracy level is low. But for categorical type of data, because it is a decision making tool only, right? If we are using such decision making tool, these algorithms are very very efficient, right? So I hope you have understood what are decision trees, where we apply these decision trees in AI, right? So hope you have understood the session, understood the topic, and you like the topic, right? You like the session. Thank you.